Hey, welcome back. Today we're going to talk about simplifying radicals. Now, let's take a look at the first one, square root of 12. Now, 12 is not a perfect square, so what we're going to do is break this 12 down. So I'm going to break this 12 down as 3 and 4. Now, watch this. Technically, that 4, we can do that as the square root of 4. What is the square root of 4? It's 2. I don't have anything to do with 3 because 3 cannot simplify anymore, and there's not a square root of 3, so we leave that underneath our radical symbol. So that is 2 square root of 3. Now, to check our work, to make sure we're doing this correctly, so this right here is my answer. So to check my work, what I'm going to do is I'm going to take this 2 that's outside of the radical symbol, or the square root symbol, I'm going to square it and multiply it by 3. 2 squared is 4 times 3 is 12. And 12 is what is underneath the radical symbol. Now, some of us may decide not to use 3 and 4, but maybe the square root of 12, we break it down into 2 and 6. Well, if you do it this way, then you got a 2 here. The 6 can also break down to 2 and 3. Now, the square root means I've got a pair of 2's. So it means the 2 comes out and 3 stays under. So take a look at either one, whether you do 3 times 4 or 2 times 6. They both give you the same answer. So for me, I don't care which way you use. I always try to look for the perfect square. Now on this one, like I said, normally what I would do is I would do 2 and 16. This is how I would normally do it. I would say, okay, 2 and 16. Then I'm looking right here. 16 is a perfect square. So I know that is 4. So it'll be 4. I'm not doing anything with that 2, so that stays in. Okay, to check my work, you take your outside 4, you square it, multiply it by the inside. So that is 16 times 2, which is 32, what I'm looking for. And I know this is a quick way. I'm meaning to do this quick because this is how I look at it. I do 2 times 16. However, some of us in here may do somewhere a different way. We may say 32 is maybe 4 times 8. Now, right off the bat, I'm looking at this 4 because that is a perfect square. So now I'm going to break down the 8. Two times 4. Look at this, I got a pair of 4's. Now, that's another way we can do it. I'm going to show you one other little way before I get to my number 3. And I apologize. I'm trying to show us a lot of different ways how to do these. So I want to kind of separate this. So if I have this 32, now maybe I do 4 and 8 again. And say if I break it down to 2 times 2, my 8 is 2 times 2 times 2. Now watch this. I got a pair of 2's, a second pair of 2's. So what that means is I take 1 2 out, took the second 2 out, leave this lone 2 by itself. So then 2 times 2 is 4, square root of 2. So there's a lot of different ways we can do this one. Now, what about this negative 6 and the square root of 20? Well, what I'm going to do is I'm going to take 4 and 5. Now, notice this. 4 is a perfect square. So what you do is you take your negative 6. I'm taking the square root of 4 out, which is 2. So 6 times negative 2, radical 5. That gives me negative 12 radical 5. Okay. What about when I have a square root of a variable? In this case, it is x to the 5th power. Well, let's break this down. What this 5 means is I've got 1x, 2x, 3, 4, 5 x's. Now, watch this. I'm going to circle my pairs. I got a pair of x, a second pair. So that means I'm bringing 2x out, which is x squared. I've got my lone x, which is underneath. This is my answer. What about when I have 25x to the 3rd power? Well, in this case, I'm going to break down the 25 as 5 times 5. Now look at my x3. That means I've got 3 x's. Now, right here is my 5. Right here, I've got a pair of x's, so I bring one out. And what's left is this right here. Now to check my answer, if you're wanting to check it, all you're doing is you're squaring your 5. Squaring your x times the x. And if you do that, that is 25. When you multiply variables with exponents, and that really is an x1, you add the exponents up, and you get 25x to the 3rd power. 36x squared y3, or y to the 3rd power. Well, this is 6 and 6. I've got 2 x's. I've also got 3 y's. Some of us in here are starting to pick this out already, I know. And you could say, okay, that's 6. So some of us are picking this out 6. So basically you can say half of the squared gives you x. And then half of y is y, and I have a remainder of 1. Or if you do this visually, like how I like to teach it at the beginning, there's my pair of 6's, there's my pair of x that I bring out, my pair of y's I bring out 1, and what's left is that y that's underneath. Okay, so this one right here, let's take a look at the 16x first. 16x breaks down to 4 and 4. My y4 breaks down to 4 y's. So, I got a pair of 4's. I'm bringing it out. I got 1 pair of y's, 2 pair of y's, so that's y squared. And what's left is x. Now, I don't know how many times I've seen people that will write it just like this, because that's easy to be confused with, especially when we're dealing with fractions. This is close to being right. So this is wrong. Okay? Take a look at this. My 4 comes out because that's in the numerator. My x stays underneath. But then when I pull out my y squared, that's how it should look. This is the correct answer. Okay, number 8. Okay, 8, 2 times 2 times 2. 27 is 3 times 3 times 3. We've seen this quite a bit. So under here, that means I've got 2 times 2 times 2 over 3 times 3 times 3. We can treat those as fractions. I got a cubed root. That means I see 3 of these. So it means I bring it out, 1 out. This is my answer, 2/3. Now this one right here is another one that we can look at. And I cannot do anything with that 11, so I'm going to hold on to that. But let's take a look at that 8. That 8, 2 times 2 times 2. That means I can bring the 2 out of the radical symbol, but I still have that on top. You can also write this as well as 1/2 like this. And finally, they try to trick you by throwing a huge number at you. So we can do, you can do prime factorization, see what number goes in. I always like looking at for a perfect square. So I'm going to say 3 can go into that 64 times. This perfect square is also a perfect cube as well. This breaks down to 4 times 4 times 4. This means I've got 1, 2, I've got my 3 of a kind. The 4 comes out. And the 3 stays under. So if you always want to check your work, okay, this is the answer that I'm looking for. If you want to check your work, you could take 4, instead of squaring it, since that's a cubed root, you would say 4 to the 3rd power times 3, and that gives you 192, which is underneath our radical symbol. So this concludes my lesson on simplifying radicals. I hope this has helped. Thank you for listening.